Okay, so let's do some more examples using integration by parts. So I look at my integral and I have natural log of x divided by x squared. Now integration by parts is written so that my terms are products. So I should really think about this as natural log of x times x to the negative 2, or times 1 over x squared. 1 over x squared. Okay, so again, I have to make the choice where one of these terms I'm going to be taking the derivative of and one I'm taking the antiderivative of. Again, since natural log is showing up in here and we don't know the antiderivative of natural log at this point, it makes it a sort of natural choice that u has to be natural log of x and v prime is our x to the negative 2. So now we find the other parts. Derivative of natural log of x is 1 over x, and the antiderivative of x to the negative 2 will be negative x to the negative 1. Which of course is negative 1 over x, if that's helpful to you. Okay, so integration by parts says that this integral of uv prime, right, this is my uv prime, is equal to u times v, so natural log of x, that's u times v, minus the integral of u prime times v. Again, remember the v gets used twice, dx. And again, this will always be a new integral with a new product that we're going to have to actually just deal with. In this case, notice that the algebra, we have a negative 1 over x times 1 over x. So this negative I'm going to pull out, and this is going to become positive, and it's just going to be 1 over x squared. And out front, I still have my, I'm going to again pull out that negative. This negative comes out front. Negative natural log of x over x. Okay, so this here is, the point is that this is supposed to be something that I can easily integrate, which I can. This is x to the negative 2. In fact, I've already found that antiderivative here. So we're almost done. Our last step is to actually find that antiderivative. So that stays the same. And my antiderivative of 1 over x squared, or x to the negative 2, is negative 1 over x. And then we add our constant, and we're done. Okay. Let's look at another example. So I have x times cosine of x. Okay, here we have to do a little bit more thinking. So again, remember parts, we're choosing one of our terms to be u and the other one to be v prime. And we get u, v. I'm just rewriting the integration by parts formula just since I'm sure you guys don't have it memorized yet, although you will. We want to choose u and v prime so that when I take the derivative of one piece and the antiderivative of the other piece, that new integral becomes something that I can easily integrate. So after a little bit of thought, it makes sense to choose u to be x, because when I take its derivative, I get something simpler, versus if I take its antiderivative, I get something more complicated. And if v prime is cosine, then the antiderivative is going to be sine. Whether I took the derivative or the antiderivative of cosine, it doesn't really get more complicated or more simple. It just sort of changes sign. So, okay, so integration by parts tells us that this result is equal to, so remember this is u times v prime, the integral of u v prime is equal to u times v minus u prime times v. And again, look at this. We have a nice easy integral, 1 times sine. We can easily take the antiderivative of. So we have x sine of x minus the antiderivative of sine is negative cosine. So this becomes a plus cosine of x plus c. And we're done. Remember that with all of these, once we're done and we find our antiderivative, of course, we can take its derivative to double check that we actually got the right result. So keep that in mind. Okay, let's look at another example. Again, I want to write this as a product. So this is e to the 1 over t times t to the negative 2. Okay, so before I go any further, I want to realize that, in fact, this problem I can use a substitution on. So even though it's in the integration by parts part of our notes, don't forget that a substitution seems more obvious here, because my inside function is 1 over t, or t to the negative 1, and the derivative of that is staring at us in the face. It's right there in the integrand, so it's screaming for an integration by substitution. So I almost have my t to the negative 2 dt here, right? Except I have a negative. So I'm going to divide both sides by that negative. Okay, so when I do my substitution, I get e to the u and the negative du. So the negative I'm pulling out. So we get negative e to the u plus c, which is negative e to the 1 over t plus c. Okay, so the point of this exercise is to remember that just because we know how to do integration by parts doesn't mean everything from now on is an integration by parts problem. In fact, the next two problems, when you look at them, here I see a substitution again, because if I choose u to be natural log of x, then u prime is that 1 over x dx, or I should call this du. That's what we were doing in class. Sorry, du is 1 over x dx. And so we have that 1 over x dx there. So I'm going to leave that as an exercise for you to finish. And in fact, that same substitution will work for part F. Okay, so I'm going to stop this video and then we'll do more examples of parts in the next video.